Hello, good day, doctor. My name is Kelvin Chai. Today I'm going to present my final year project. My title is An Algorithm in Size and Weight Measurement for Intact Pineapple. My supervisor is Dr. Chia Kim Seng. The first one is the background of study. From 2016 to 2020, Malaysia's pineapple export have been an upward trend, especially the local varieties such as MD2, N36, and Josephine, with high demand from China, Philippines, and Indonesia. Image represents a significant subset of all measurements made. Image processing algorithm can solve various image tasks. For example, in digital image detection, image data comparison, spectral image estimation, and image estimation. OpenCV and Python is the most suitable software tool to implement the size and weight measurement by using image processing algorithm. Next, about the problem statement. In the past, farmers usually measure the size of each pineapple manually. It is very take time and the work efficiency is very low. For the small owner, they need to spend more time and energy to complete the work. Next is the objective. There are three objectives in this project. First is to develop a vision system for capturing the pineapple. Second is to develop an image processing algorithm using OpenCV and Python. Third is to elaborate the accuracy of the image processing algorithm using OpenCV and Python in size and weight measurement. Next is the scope of study. First is to use the image that captured from the Philips PSE05110 webcam with 2 megapixels effective pixel, white dynamic and automatic white balance. Second is OpenCV and Python with 3.9.7 version is used to develop and execute the image processing algorithm. Third is to detect the size in diameter and length and predict the weight measurement from image with different type of pineapple, which are the Morris, Romping, Josephine, and Sarawak. So the next part is the methodology. The first one is the vision system setup. So this system is set up by the webcam and 3 lightning device. The webcam is set at the top of the sensing area, and the lightning device is set at the 3 sides of the sensing area, and the pineapple will place at the bottom of the camera. So the distance from the camera to the background is 29 cm in this project. So for data execution, the first step is mark the angle in 0 degree, 120 degree, and 240 degree at the bottom of the pineapple. The second step is place the pineapple at the sensing area and capture it in 5 different positions. Third step is measure and record the length, diameter, and weight of pineapple. The fourth step is repeat the second step and third step in different degree, which is 120 degree and 240 degree. Repeat all the steps above with other pineapple. So the next part is image processing. So there are some image processing methods are using in this project. The first one is noise reduction. This is the technique to reduce the noise and make the image more smooth. And second is the morphological operation. So there are 2 basic of the morphological operation, which are the erosion and dilate. So the erosion is used to erode the boundary of the foreground object and diminish the feature of an image. The dilation is used to increase the object area and joining the broken part of an object. The third is the edge detection. It detects the edge to find the change in the neighboring pixel. The fourth one is the color conversion. The color conversion from RGB to grayscale we use in this project, and it can reduce the model complexity. So for the size and weight prediction, the size prediction we're using the pixel per metric ratio method, and the weight prediction of the pineapple we're using the linear regression. So the below is the formula for the linear regression. So y will be the dependent variable, which is the weight what we predict, and b0 and b1 b2 will be the coefficient. It will calculate by the linear regression with the Python code. And the x1 and x2 is the independence variable, which is the size in diameter and length. For the result of the size and weight precision, will execute by the Python. Next is the performance evaluation. There are 2 parts. One is for size and the second is for weight. For the size, there are 2 methods to evaluate. So for the percentage error will be comparing the result by software and result by manual. For the RMSE, which is the root mean square error, which is the average distance between the result by software and the result by manual in the dataset. So for the weight prediction, The accuracy of the prediction is based on the correlation value. It is the strength of the linear relationship between the dependent variable and independent variable. If the result of the correlation value is more toward to the 1, it will be more reliable and have the strong correlation relationship between independent variable and dependent variable. Next is the demonstration in the Python. In this part, I will run and execute the image processing algorithm in Python and show the result. First is detect the reference image to get the pixel per metric ratio. So the image we set, the image X is our reference image. So now we'll look at the image X. So this is the image X. So the real diameter is for the image X is 13.0 and the real length for the image X is the 15.2. So the step from line 19 until line 35 is the image processing algorithm to enhance the image so that we can get the contour. Now we run the code. So from here we can see that there is the bounding box here. So the width of the bounding box can use as the diameter of the pineapple, and the length of the bounding box is the length of the pineapple. So this is so from the line 41 until the line 111 is the method to use the bounding box to detect the contour and then get the length and the diameter. So for the dA is the height, which is the length of the bounding box, and the dB is the width of the bounding box. So by using these two values, we can get we divide with the real image, which is the 13.0 for the diameter, 15.2 for the length, so we can get the ratio of length and diameter. And these two value can be insert to the another code so that we can detect the others pineapple. After we get the ratio of the length and ratio of the diameter, we put these two values into the pineapple detection code. So the pineapple detection code and the reference code, the only difference is the last part, which is the compute the size of the pineapple. So the dA is divided with the real length for the reference, and the detection is dA divided with the ratio. So this equation can get the predicted value of length and also the diameter. So let's run the code. So the image we select is the image 68. So from the result, we can know that the predicted length is 10.6 and the predicted diameter is 10.06. So all the data I already key in into the Excel file. So for the second row and third row is for the manual measure diameter and length. For the fourth row and the fifth row is the result we get from the Python, which is the predicted diameter and predicted length. And the arrow is the manual minus with the software divided by the manual and times 100%. So that this is all the percentage error. So now we look at the image 68. So for the image 68, the diameter compared with the manual method and the software method, the error just 0.6%, and for the length is just 0.09. So that we can assume that this algorithm is very high accuracy. And the fifth row is the weight. So this software result and the weight will be moved to the third part, which is using the weight prediction. The third part is the weight prediction by using the linear regression. So we will read the data from the CSV file, which is the ML pineapple data.csv. So this CSV file is move the data from the predicted diameter and length and the weight to this CSV file. So the x1 will be the predicted diameter and x2 will be the predicted length and y will be the width. So let's run the code. So from this code, we can get the accuracy. The accuracy is the correlation coefficient. So when the correlation is moved toward to the 1, it means that the data will be more accurate. So since there is 94.56%, it means that the prediction is highly accurate. So for the result for formula for the linear regression, the intercept is negative 2033. For the variable length is the 179 and the diameter variable is 79. So this is the graph for the weak prediction. Next is the result and discussion. So the first is the size detection. The highest percentage error for the diameter is 2.77% and for the length is 2.84%. For the lowest RMSE is the weight of 1618 gram pineapple, which is having the 0.0465 cm for diameter and 0.0258 cm for the length. For the highest RMSE is the weight of 831 gram pineapple, which is 0.1457 cm for the diameter and 0.1573 for the length. Since the percentage error is very low, so that we can assume that the result is reliable. For the weak prediction, it can show that the SEC means that the correlation, since the SEC is 0.9456, so it is very toward to the 1, so that we assume that this model is reliable, and the below is the intercept and the diameter and length, which is the B for the bias for the formula of the linear regression, and the below is a graph is generated by the Python. So in conclusion, compare the result by the software and result by manual. The highest error for the diameter is 2.77%, for the length is 2.84%. For the weak prediction, there is 94.56% of strong correlation between the size and weight. It means that the size and weight of the pineapple is able to be detected and predicted. So the result by software is reliable. That's all for my presentation. Thank you.